Okay, and now in this last video, what we're going to do is complex fractions again, this time by multiplying by 1. And people sometimes get frustrated when there's more than one method. I really do feel like with this though, is sometimes I do method 1, sometimes I do method 2. If I get stuck on method 1, sometimes I'll try method 2. You know, like it's nice to have a backup or a way of checking to see if you're doing it right. Now, method 2 uses a rule called multiplying by 1, which is that there's the multiplication property of identity, which is that you can take anything and multiply it by 1 and you never change its identity. We use this a lot when we're creating common denominators. So if I wanted to give this a denominator of 6, I could multiply by 2 over 2. What I'm really doing is I'm multiplying by 1. I'm not changing the value of the fraction to make it 4/6 because I've multiplied by 1, so I haven't changed its identity. So knowing that rule, when you have a complex fraction, what you're allowed to do is you're allowed to multiply by 1, right? So what we multiply by is the lowest common denominator of both the denominators. So there's a denominator in your numerator, there's a denominator in your denominator, and you determine what is the lowest common denominator. So for me, I'm going to look at y and 3y and say that my lowest common denominator is 3y, and then you're going to multiply by 3y over 3y. By doing that, I'm not changing the value of my fraction because I'm multiplying by 1. But what that's going to do is you're going to multiply your numerator by 3y, and you're going to multiply your denominator by 3y. And then I usually call this method the destruction method. So it's really messy, because it's destroying the denominators. So what we're doing is we're getting rid of the part that's complex. So 3y divided by y, the y's will cancel, or divide to give you 1, and then 3y divided by 3y is also 1. So then I'm left with y plus 2, or 3 times y plus 2, over y minus 2. And you'll notice if you scroll up to method 1, that we get the exact same answer. So these are the exact same questions that we're doing again, just with method 2, and so you should get all the same answers. So then you look at a question like this one, and you have to realize that these guys have denominators of 1, so you're taking the common denominator of every denominator. So there's a 1, an x, a 1, and an x, so my lowest common denominator is going to be x. So again, I'm going to multiply by x over x. When you do this, you have to remember that we're distributing an x through the numerator and we're distributing an x through the denominator. So we're multiplying the whole numerator by x and the whole denominator by x. The way that I show this is I multiply every single part of the numerator by x, and then I multiply every part of the denominator by x. And then all of my things that make it complex, so all of my fractions within the fraction, will simplify. So then I'm left with 4x minus 3 over 5x minus 1. And if you look at how much work method 1 was, right? So we had to create a common denominator, then we had to flip and multiply and simplify and all the things, but we get to the same answer, 4x minus 3 over 5x minus 1. Easy peasy. So most people do prefer this method too, but there's a few people who are just like, but it's weird. Why am I multiplying by something? And I don't like that. And so then I'm just like, do BEDMAS, right? Follow the rules of operation. So for this one, my lowest common denominator would be an x squared and a y squared. So I'm going to take every single term. I should keep my format. I don't ever put this step. I always show it like this. So I like taking my lowest common denominator and just right away multiplying every term by it. I do like showing this step for sure. Okay, people who don't make mistakes. So then we're going to go x squared y squared over 1 over x plus x squared y squared times 1 over y. Okay, and then the whole point of doing this is that all my denominators should cancel out. So x squared takes out the x squared, y squared takes out the y squared, the x takes out the squared, and the y takes out the squared. So you just have to be really careful. The other reason people don't like this method is it's a little bit messy. So you have to look at this and be like, okay, what am I left with? I'm left with y squared times 1 minus x squared times 1 all over. Now this is an x y squared times 1 plus an x squared y times 1. Now this guy's not done. Now I would have to simplify. So back to that first, or I guess the second lesson of this review. So in my numerator, I have a difference of squares. So y minus x, y plus x. And then in my denominator, I have a greatest common factor of xy. Then I can look at that and I can simplify. Boom, boom. And I am left with y minus x over xy. So that's method 2. So what I would recommend you do now is pause the video and then try those 3 questions that we did previously with method 1 with method 2 just to make sure that you've got it. This first one might kind of make you pause. You know, you're like, oh my gosh, well, now what? So you have 2 choices with this one. This one is a great one to do method 1, or what I would do first with this one is maybe factor. So this is 5 over y plus 2 all over negative 3 over, this is a difference of squares. So remember, whenever you're finding a lowest common denominator, you want it in factored form, right? We've been practicing that all the way along. So now you can see that your lowest common denominator is y minus 2, y plus 2. And so then you're going to multiply every term by y minus 2, y plus 2 times 5 over y plus 2 all over y minus 2, y plus 2 times negative 3 over, it's a lot of writing, y minus 2, y plus 2. All right, so then what do? We simplify. So the y plus 2 takes out the y plus 2, and these both get taken out. So then I'm left with 5 times y minus 2 all over negative 3. Now I don't like negatives in the denominator, so if you look at your answer key, it might have the negative moved up to the numerator, or it might be out front, but recognizing that these are both the same. Did I have that negative in the other one? Let's just check. Huh, I was okay with it here. I shouldn't have been. Maybe I was just so proud of us for doing method 1. Again, I would write it with a negative in the numerator. All right, next one. Lowest common denominator would be a squared b squared. So I'm just going to show you what I really do. Should I? Yeah, I just go like this. You know, if you have the question written down. And then I simplify. And then be very careful. Some people won't do all the simplifications. Sometimes they'll just do one at a time and then simplify that part. So what am I left with? I'm left with ab squared minus a squared b all over b squared minus a squared. Feels very similar to that other one we did. I'll take out the ab, be left with b minus a. I'll factor this as a difference of squares. And then I'll simplify. And I'm left with AB over B plus A. Awesome. And then there's that last one. People always get confused about this one. And sometimes it could help you to write it as S over 1 minus R over 1 to realize that your numerator is a fraction. You just don't see them. But sometimes this can just help people understand what's going on. So if I look at this, I have denominators of 1, 1, R, and S. So my lowest common denominator is just going to be an RS. And then I multiply every term by that RS. So that my denominators go away. Boom, 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 boom. And then what am I left with? Well, I know this question, and I know that I actually don't want to multiply this. I would love it if you recognize that this is RS times S minus R, but most people won't. So let's just do it the way it's written. So we'd end up with RS squared minus R squared S all over S minus R. Now, if you hadn't multiplied these through, you would have had RS times S minus R. It would already be in factored form, but we multiplied through, so now we have to greatest common factor. Not a big deal, but I find most people understand it when I write it this way. So I'm going to factor out the RS to be left with S minus R over S minus R, and then these will cancel out, and I will be again just left with RS. Awesome. So pick your method, do them both, do one when it looks like this or one when it looks like this, or try both if you're stuck, but they're both available for you.